Good day, ma'am. I'm Queenie Andalupam from BSN1 OREM Group 8. So for today, we will talk about the fluid, acid-base balance, and electrolytes. So these slides highlights the interconnectedness of fluid, electrolyte, and acid-base balance. So these are essential for life, supporting the health and functions of all body systems. Electrolytes like sodium and potassium are crucial for nerve function, muscle construction, hydration, and blood pressure. Maintaining proper pH is vital for enzyme function and overall metabolisms. Imbalances can lead to serious health problems, like diabetic ketoacidosis or DKA, illustrates the critical importance of fluid, electrolyte, and acid-base balance. Lack of insulin causes ketone production, leading to dehydration, electrolyte loss like potassium, and metabolic acidosis. These combined imbalances can be life-threatening, highlighting the interconnectedness of these systems for health. Slide contains extracellular fluid or ECF, which constitutes about 30% of total body water. ECF is divided into three compartments. Number 1, the interstitial fluid that surrounds cells, facilitating nutrient and waste exchange. Number 2, intravascular fluid or the plasma, the liquid part of blood, carrying cells, nutrients, hormones, and waste. It's essential for blood pressure and volume. Number 3, the last one, the transcellular fluid. This is specialized fluids like cerebrospinal fluid or CSF, pleural fluid, peritoneal fluid, and seneval fluid, found in specific body cavities and having unique functions like cushioning and lubricating. Now we will talk about the intracellular fluid or the ICF. Makes up about 70% of total body water. It's rich in potassium, magnesium, and phosphate ions, crucial for cellular functions like metabolism, energy productions, and maintaining cell membrane potential. ICF is the site for many metabolic processes including protein synthesis and cellular respiration. The next slide explores the roles of phosphate and sodium in bodily fluids and introduces the concepts of isotonic and hypertonic solutions. Phosphate. So this is essential for ATP production, the energy source for cellular metabolism. So I will give you some examples. So imagine a construction worker or the cell building a house, which is the complex molecule. They need energy or the ATP to lift materials, mix cement, and etc. Phosphate is vital for producing that energy. Without it, the construction or the metabolic processes would come to a halt. Next one is sodium. So, a fluid with a high concentration of dissolved particles is considered more concentrated than the one with the fewer particles. So, I will give you a scenario. When you salt a cucumber to make pickles, you're creating a hypertonic environment. The high salt concentration outside the cucumber cells draw a water out of them, causing them to shrink and become firm. So now we will know the difference between isotonic and hypertonic solutions. So first is the isotonic solution. So this is a fluid with the same tonicity as normal blood. So for example, a patient experiencing severe dehydration due to diarrhea would like to receive an isotonic IV or solution like normal saline to quickly restore fluid volume without causing further harm to their blood cells. Hypertonic solution, this is a fluid that are more concentrated than normal blood. So imagine placing red blood cells in a solution of highly concentrated salt or the hypertonic saline. The salt concentration is much more higher outside the cells than inside. Because of this, water will leave the red blood cells and move into the surrounding saline solution. This causes the red blood cells to shrink and shrivel, a process called crenation. Red blood cells in different solutions demonstrate tonicity. Isotonic solutions maintain cell shape. Hypotonic solution cause cells to swell and lease, and hypertonic solution cause cells to shrink and crenate. This illustrates the critical importance of maintaining proper solute concentrations in bodily fluids for cell health and overall functions.
The factors that influence body water distributions are age, Gender, infants, 80% water, are at higher risk of dehydration than adults. Males, 60%, females, 50%, because infants have a higher proportion of easily lost extracellular fluid. Females have less water than males due to higher fat content, and obese individuals have less water and lean individuals, increasing their dehydration risk. Functions of body water. First is extracellular fluid compartment or ECF, intracellular fluid compartment or ICF. Next is maintenance of normal body temperature. Number 4 is elimination of waste. So these are the functions of electrolytes. It promotes neuromuscular irritability, maintain body fluid volume and osmolality, distribute body water between fluid compartments, and it regulates acid-base balance. So when we say electrolytes, it is the fluid in the body compartments contains mineral salts, also known as electrolytes. So imagine that your body is like a giant complex city. Electrolytes are like the tiny messenger that to keep everything running smoothly. They are minerals that become charged when they are in water, like little batteries. So the sodium and potassium, these are like the city's traffic light signals. It helps the nerve cell to send message quickly. They also help your muscle contract and relax. The calcium and magnesium, these are like the city's construction workers. They help the body to maintain strong bones. Next is chloride, phosphate, and bicarbonates. These are like the city's sanitation workers, helping to maintain the right balance of fluid and acidity in your body. So just like the city needs its messenger, your body also needs its electrolyte to stay healthy. So these are the functions of electrolytes. It promotes neuromuscular irritability, maintain body fluid volume and osmolality, distribute body water between fluid compartments, and it regulates acid-base balance.
Function of electrolyte. Number 1, promote neuromuscular irritability. Ito naman tinutulungan ng electrolyte ang muscle at nerve natin gumalaw at mag-respond ng mabilis. Number 2, maintain body fluid volume and osmolality. Sila ang nagbabantay para hindi tayo ma-dehydrate at para maayos ang balanse ng tubig sa katawan. Number 3, distribute body water between fluid compartment. Ito naman inaayos nila kung saan dapat mapunta ang tubig sa iba't ibang parte ng katawan, halimbawa lang sa loob o labas ng cells. Number 4, regulate acid-base balance. Sila ang tumutulong para hindi maging masyadong acidic or alkaline ang katawan natin. Potassium, important in the conduction of nerve impulses and promotion of proper skeletal and cardiac muscle activity. Ito naman kailangan para sa tamang pagpadala ng nerve signal at para sa normal na paggalaw ng kalamnan sa puso at sa katawan. Calcium, calcium and phosphorus 99% found in the bones and teeth, 1% in the blood. Karamihan ng calcium ay nasa buto at ngipin at konti lang sa dugo. Importante ito sa bones, blood clotting at muscle function. Paano gumagalaw ang electrolyte? Sa pamagitan ng active transport. Ginagamit ang urea para ilipat ang electrolyte laban sa concentration gradients galing sa mababa papunta sa mataas ng concentration. Sa labas naman ng cells o ECF, mataas ang sodium, chloride at bicarbonate. Sa loob naman ng cells, mataas ang potassium, magnesium at phosphorate. Ang diffusion naman, hindi kailangan ng urea. Gumagalaw ang electrolyte mula sa lugar ng maraming concentration papunta sa lugar na kaunti para maging pantay ang distribution. Nangyayari ito sa pagbukas ng ion channel sa cell's membrane na mahalaga sa nerve at muscle function.
Hi, I'm Zora Tande and I will discuss first the osmosis. First, you've got the basic idea of osmosis down. It's indeed the movement of water across a selective permeable membrane like a cell membrane from an area of higher water concentration or lower solute concentration to an area of lower water concentration or higher solute concentration. This movement aims to equalize the concentrations of particles or solutes on both sides of membrane. Think of it like this. Water wants to dilute the more concentrated solution. Let's break it down further with an example. Imagine a simple container divided by a membrane that only allows water to pass through. Side A contains pure water. Side B contains water with good amount of dissolved water. Initially, the water concentration is higher on side A, and the solute salt concentration is higher on side B. Now, what happens due to osmosis? Water molecules from side A will move across the membrane into side B. This happens because higher concentrations of salt on side B effectively attracts the water molecules, trying to dilute the salt solution and equalize the solute concentrations on both sides. The movement of water will continue until the osmotic pressure on both sides of the membrane is balanced, or until equilibrium is reached. You might notice the water level on side B rising, the water level on side A falling. Why is this important for cells? Osmosis is crucial for maintaining the proper volume and functions of cells. For example, plant cells rely on osmosis to maintain turgor pressure, which keeps them rigid and upright. When a plant wilts, it's often due to a loss of water and turgor pressure through osmosis. Next one. Red blood cells are very sensitive to changes in osmotic pressure. If placed in solution with a much lower solute concentration, or hypotonic solution, water will rush into the cell, causing it to swell and potentially burst, or hemolysis. Conversely, if placed in a solution with much higher of solute concentration or hypertonic solution, water will move out of the cell, causing it to shrink and shrivel up, or crenation. The kidney in our bodies use osmosis to regulate water balance in the blood. In essence, osmosis is a fundamental passive process. It doesn't require energy input by the cell that plays a vital role in maintaining cellular homeostasis and various psychological processes throughout living organisms. Does this further explanation and example help clarifying things for you? Okay, let's proceed to the fluid balance. Okay, let's illustrate the importance of hypotonic sodium-containing fluids or water with a bit of salt in maintaining fluid balance with an example. Imagine a person, let's call her Maria, who lives here in Tacurang City, Sacsayhuaman, Philippines. It's a typical hot and humid day. Maria spends a few hours working in her garden. Fluid output. Sweating. Due to the heat and physical activity, Maria sweats quite a bit. Sweat contains not only water but also electrolytes, including sodium and chloride. Second, urination. Maria will also lose some fluid through urination throughout the day. Third, insensible losses. She will lose a bit of water through breathing and evaporation from her skin without even realizing it. Let's say through these various routes, Maria loses approximately 2 liters of fluid over the course of the day. This loss includes a certain amount of sodium. Maintaining fluid balance, the right intake. To maintain her fluid balance, Maria needs to replenish these 2 liters of fluid loss. Now, let's consider different scenarios for her fluid intake. Scenario 1. Drinking only pure water. If Maria only drinks 2 liters of pure water to replace her losses, she's replenishing the water volume but not the electrolytes she lost in her sweat. This can lead to a condition called hyponatremia. where the concentration of sodium in her blood becomes too low. Why this happen? By drinking pure water, she is diluting her body fluids, including the sodium concentration. Her body will try to correct this balance by increasing urine output to get rid of the excess water. However, she might still end up with a lower normal sodium level, which can cause symptoms like headache, nausea, dizziness, and in severe cases, confusion or seizures. And then, why is hypotonic important? If Maria were to drink a hypertonic fluid, higher solute concentration than her body fluids, like a very sugary soda, it could actually draw water out of her cells and into her intestines due to osmosis. This would temporarily worsen her dehydration. In conclusion, Maria's example highlights that simply replacing the volume of fluid lost isn't enough, especially when there's significant sweating involved. Consuming a hypotonic fluid that contains some sodium, either through the dedicated sports drink or by slightly salting water along with a regular diet, helps to restore both the water and the crucial electrolytes lost, ensuring that her body maintains proper fluid balance and functions optimally in the hot climate of Tacloban City. Does this example make the concept clearer? Let's proceed to our next topic. You're right. An average daily fluid intake of around 2,200 ml or 2.3 liters is a good general guideline for healthy adults. It's important to understand where these fluids come from and why maintaining adequate intake is so vital. Let's break down the sources of this intake and then illustrate its importance with an example relevant to someone living in Tacloban City. Sources of daily fluid intake: drinking approximately 1,500 ml or 1.5 liters. This is the most correct and often the most variable source. Most direct, rather. It includes water, juice, milk, tea, coffee, and other beverage. The amount we drink is influenced by thirst, habits, social factors, and supports, and the surroundings environment, like the hot weather in Tacloban City. Second, eating approximately 750 ml. Many foods have high water content. Fruits like watermelon, pineapples, and orange readily available in the Philippines. Vegetables like cucumbers and tomatoes. Soups and even cooked grains contribute significantly to our daily fluid intake. Metabolic water, approximately 200 ml. This is water produced as byproduct of metabolic processes within the body, such as the breakdown of carbohydrates, fats, and proteins for energy. While its smaller contribution compared to drinking and eating, it's still vital internal source of fluid. Other routes, variable and often related to medical needs. As you mentioned, fluid can also be administered through intravenous or IV lines, rectal administration or enemas, and other cavity irrigation. These routes are typically used in specific medical situations to provide hydration or deliver medication. Why adequate fluid intake is crucial, an example in Tacloban City. Let's go back to our resident of Tacloban City, Maria. Given the hot and humid climate, her fluids needs are likely higher than someone living in a cooler environment. Imagine Maria on a particularly active day. She wakes up, drinks of a glass water around 250 ml. For breakfast, she has some fruit, say a mango, which contributes to her fluid intake. Throughout the morning, she drinks another glass of water and a cup of coffee, another 50 ml combined. Then she spends several hours at the local market walking around under the hot sun. She buys some vegetables and fruits, which will later contribute to her fluid intake when she eats them. However, due to the heat and activity, she sweats significantly. losing a substantial amount of fluid. If Maria doesn't consciously increase her fluid intake beyond her usual habits, she could easily become dehydrated. Here's how inadequate fluid intake could negatively impact her. Reduced energy levels and fatigue, impaired cognitive function, difficulty regulating body temperature and constipation, increased risk of kidney problems, dry skin and mucous membranes. And to maintain adequate fluid intake, especially in a hot climate like Tacurong City, Maria should drink water regularly throughout the day, even before feeling thirsty. Thirst is a sign that dehydration has already begun. Increase fluid intake during and after physical activity. Consume water-rich foods like fruits and vegetables. Be mindful of the color of her urine. Pale yellow indicates good dehydration, while dark yellow suggests she needs to drink more. In conclusion, the average daily fluid intake of 2,300 ml is a starting point, and individual needs can vary. However, consistently ensuring adequate fluid intake through drinking, eating, and being mindful of environmental factors like the heat in Tacurong City is crucial for maintaining overall health, energy levels, cognitive function, body temperature regulation, and the proper functioning of various bodily systems. Does this example help illustrate the importance of fluid intake?
Acid-base balance, regulation of acid-base balance. Hydrogen ion are vital to life and health. Hydrogen ion's concentration is expressed as pH. Chemical vapors. Carbon acid bicarbonate vapor system. Carbon acid is formed by the combination of carbon dioxide and water. 20 parts bicarbonate, 1 part carbon acid. Maintained by lungs and kidney, phosphate vapor system active in kidney. Protein vapor system, HGB or hemoglobin is one of the protein involved. Action time of chemical vapors is instantaneous. Respiratory control of pH. Control carbon dioxide concentration and ECF. Action time minutes to hour. Renal regulation of pH. Control bicarbonate concentration in AC. Acid-base balance. So, unang-una po, importante po na ma-maintain natin ang acid and base balance sa katawan natin. Kasi nakaka-apekto ito sa normal na function ng cells at organ. Ang concentration ng hydrogen sa katawan ay nagdi-determine ng pH level. Kapag mataas ang hydrogen, acidic ang katawan. Kapag mababa naman, ay basic or alkaline. Para ma-maintain yung balance, meron tayong ginatawag na chemical vapors. Ito yung mga system na nag-adjust agad para hindi tumaas o bumaba masyado ang pH. So, una, meron tayong carbonic acid bicarbonate vapor system. Nabubuo ang carbonic acid kapag nagsama ang carbon dioxide at tubig sa katawan. Dito, kailangan ma-maintain yung ratio na 20 part bicarbonate ng 1 part carbonic acid para maging stable ang pH. Ang lungs at kidney ang nagtutulungan para i-maintain ito. Meron din tayong phosphate vapor system. Active naman siya sa kidney at tumutulong sa pag-regulate ng pH lalo na sa urine. Lastly, meron tayong protein vapors. Isa sa mga importanteng protein ay ang hemoglobin sa dugo. Tumutulong din sa pag-buffer ng hydrogen ion. Ang kagandahan po ng chemical vapors, instantaneous sila. Ibig sabihin, mabilis sila mag-react kapag nagbago ang pH ng katawan. So, aside po sa chemical vapors, may dalawa po tayong major na paraan para ma-regulate ang pH ng katawan. Ang respiratory control and renal control. So, ang respiratory control, ang lungs po ang nagkukontrol ng dami ng carbon dioxide sa dugo. Kapag mabilis tayong huminga, hyperventilate. Bumababa ang carbon dioxide sa katawan, kaya bumababa din ang acidity. Kapag mabagal naman tayong huminga o hypoventilate, naiipon ang carbon dioxide kaya tumataas ang acidity. Yung action time po dito mabilis lang, usually minutes to hours. So sa renal control naman is kidney po ang nagkukontrol ng bicarbonate sa dugo. Kapag kailangan, naglalabas o nire-retain ng kidney ang bicarbonates para mag-correct ang pH.
Medyo mas mabagal yung process, umaabot ng hours to days, pero mas long-term at stable ang adjustment. In short po, sabay nagtutulungan ng chemical buffers, lungs at kidney para hindi masira ang balance ng pH natin at mapanatili ang healthy functioning ng katawan.